Okay, in part A, we're basically going to try to find the range that where does the package strike the ground relative to the point at which it was released. So that's basically we're going to use a range. First step is going to be to find the displacement, or delta y, which is equal to y minus y of 0 equals v of 0 y t minus 1/2 g t squared. So we're going to substitute our y of 0 in this equation. To y of 0 is going to be 0. Your velocity, your v0y is going to be set to 0, and you're going to set y to negative 1 times 10 to the second power meters. And the final vertical position of the package relative to the airplane, and then we're going to solve for time. So to do that, y is going to equal a negative 4.90 meters per second squared over time squared is equal to 0.1.00 times 10 in the second meters. And when we solve for t, we come out to 4.52 seconds. Next thing we want to do is find the x displacement. So we're going to substitute x of o for 0. VO of x is going to be for your 40.0 meters per second, and the time. So to solve for this, we have x equals 40.0 meters per second, and we use our time from earlier, which is 4.52 seconds, which then would come out to 181 meters. It says for range we're trying to solve for, well, the x direction. This one right here is going to be our final answer for part A. Now for part B, it says what are the horizontal and vertical components of the velocity of the package just before it hits the ground. So in this case, we're going to find the components of the package's velocity at impact. So we're going to find the x component of the velocity at the time. And to do that, we're going to use the formula v of x equals v of 0 cosine of theta, which when we plug in those numbers is 40 meters per second times our cosine of 0, which equals 40.0 meters per second. That's on our x direction. Our velocity in our y direction, the components of the velocity at the time of impact in the y direction, v of y is going to equal to v of 0 sine of theta minus gt. Which then equals to 0 minus 9.8 meters per second squared times 4.52 seconds, and when we compute that, we get a negative 44.3 meters per second. And that is our x component and y components of velocity just before it hits the ground. This is Michael Diamond, and this is standard number 4.